Hello everyone, this project demonstrates MRI image reconstruction using deep learning model called VARNet. MRI scanners capture raw data in k-space frequency domain, and reconstructing high quality images from undersampled data is called challenging task in medical imaging. In this system, we use trained VARNet deep learning model to reconstruct the MRI images and deploy it using fast API so that reconstruction process can be accessed through an API. And the project consists of several important files. There are app API which contains our fast API server and API endpoints, and there is model PY which has load the data, train data Warnet model, and util has performs interference and calculates matrices. And in model files is responsible for loading the trained Warnet model. In this file, we define the model architecture using the fast MRI Warnet implementation. Then we load the pre-trained weights from the checkpoint files like train datasets, and the model is new moved to available devices, either CPU or GPU, and set the evaluation mode, which ensures that it runs only for interference and not for training. If a GPU is available, the model can also run using half precision for faster inference performance. And in util this file implements the MRI reconstruction pipeline. First, the input MRI H5 file is opened using the HDF5 library. These files contains the k-space data and sampling mask using MRI acquisition. The k-space data is converted into PyTorch tensors and passed through the Warnet models to generate the reconstructed MRI images. In addition to the reconstructed image, we also generate a zero field reconstruction, which is basic reconstruction obtained using an inverse Fourier transform. Finally, we compute PSNR and SSIM matrices and create a heat map showing the difference between the reconstructed image and the zero field image. In app.py, the fast API application is implemented in the app file. Here we create an API endpoints called iPredict, which accepts an MRI H5 file as an input. The API saves the uploaded file temporarily, sends it to inference pipeline, and then generates the output visually. The output image combines three panels: the zero filled MRI image and the reconstructed MRI image generated by the model, and the heat map highlighting reconstruction differences. Now we will see the terminal. Here now we start the fast API server using Unicorn. Once the server starts, fast API automatically generates the interactive API document. Now let's see how the browser works. This page shows the interactive API documentation generated by Fast API. Here we can test the predict endpoints by uploading an MRI datasets. The API processes the k-space data, runs the deep learning reconstruction model, and generates the output visualization along with PSNR and SSIM evaluation matrices. Now we will upload our image and it will give the output. The output visualization contains three panels. The first panel shows the zero filler reconstruction, which is the baseline MRI reconstruction method. The second panel shows the deep learning reconstruction procedure by the Warnet model, which improves image quality and reduces the artifacts. The third panel shows a heat map highlighting the areas where the model has modified the image during reconstruction. And finally, the reconstruction quality is evaluated using PSNR and SSIM matrices. The PSNR measures the signal to noise ratio between the images, while the SSMI measures structural similarity. Higher values indicates better reconstruction quality. And in the conclusion, the project demonstrates how deep learning model such as Warnet can improve MRI reconstruction from undersampled case-based data. By deploying the model using Fast API, we create an easy-to-use system that performs MRI reconstruction and visualize the results along with the evaluation matrices. So, thank you.